All right, so we're still dealing with bonds, which are bond valuation. All right, we've got a twist in our question here. All right, Mr. Jackson invests in a bond of 1,000 face value, nominal value, par value, book value, with an 8% coupon rate. This is the interest rate with 6 years to maturity. The yield to maturity is 5%. What is the market price of the bond if interest is paid semi-annually? All right. So if interest is paid semi-annually, it is paid two times in the year, right? Semi-annually. We have to make some adjustments. Okay. Semi-annually. N equals 2, right? The number of payments, all right, since it's the 6 years yield to maturity. All right. So every 6 years, every year you'll be getting paid twice. All right. In year one, you get paid twice. Year two, you get paid twice. So the total number of times you'll be paid is two times. So say 2 times 6, n times t, which is 2 times 6. So we're going to be paid 12 times. In 6 years, we're going to be paid 12 times. All right. All right, then another adjustment we have to make. All right, so since the interest is paid semi-annually, all right, our yield to maturity, we're going to divide it. So we say yield to maturity, all right. So since our yield to maturity is 5%, remember the yield to maturity, this is the required return if the bondholder keeps the debt until it matures. So yield to maturity, we have to divide it by 2 since interest paid semi-annually, that is twice. So we're going to say 5% divided by 2, that gives us 2.5%, right? Our coupon rate 2 has to be adjusted, coupon rate or interest rate. We divide it by 2, right? All because we're getting paid semi-annual, right? If we were getting paid quarterly, this would have been 4 and would have multiplied 4 times 6, divided 5% by 4, or divided our coupon rate by 4. All right. So our coupon rate, which is 8%, so I'm going to say 8% divided by 2. 8% divided by 2, which is going to be 4 cents. All right. So our interest payment too. Interest payment. Let's see what our interest payment is. Since our coupon rate has gone down, remember the interest payment is the interest rate times the par value. All right. So our interest rate, we're not going to use 8%. We're using 4%. So when it's 4/100 times 1,000, right? That's how we get the interest payment, right? The interest rate times the par value. So the interest payment will be 40 kwacha. All right. So in a year, once we buy this bond or purchase this bond, we'll be getting paid interest payments twice that year. All right. Now we can find the market value of the bond. No, price of the bond, market price of bond. Right. We use our formula here. IPVIFA. That's the annuity factor for interest payments. Remember, here we're trying to convert these future payments into our present value. So basically, this price of the bond basically is we're also trying to find the present value basically. All right. Plus, all right, our par value multiplied by the present value. Right. Our present the number that found with our present value. with our discount factor we got on our present value table. Yes. So this is the formula of the price of the bond. All right. So on our tables, first we're going to look for our annuity factor, then our present value factor. Right. So our interest payment is 40. Our annuity factor. So on our annuity table, N is going to be 12. And our yield to maturity, since it's 2.5%, our discount factor is 2.5%. So we might have to use the formula. We might not be able to use the table. So let us use the formula for our annuity factor. 1 minus, I hope you can see this, right? Because we do not have 2.5% on our annuity table. So our annuity factor, this is 1 minus 1 plus r to the power negative n to the power r. All right, so this negative n will be 12. This r is 2.5%. Okay, so on our yield to maturity here, we're going to say, let let me put a fraction here. Oops, I don't know why it's taking so long. Right, here we go. The wrong place. Let me take it from here. All right, so we're going to have to put it here. So our formula is 1 minus, just confirm, 1 minus 1 plus r, plus r to the power, excuse me, the power, let me see, how do we put a power here? The power negative 2, yes, the power negative 2, right, divided by, right, divided by, I believe it's r, which is divided by r, right, plus our power value 1000, our present value factor, all right, since our yield to our discount rate is 2.5%, so use the formula for the present value, which is 1 plus r to the power negative negative t, which will be represented as our n, which is 12. Let me just confirm something here. Oh, 1 plus r to the power negative n. Negative n. All right, so we find our 40. Oh, this wasn't supposed to be to the power negative 2, to the power negative n. Oops. I don't know why I put negative 2 there. All right, so we just do our substitutions. Okay, so R is 2.5%. 2.5 divided by 100. Let me see. 0.025. N, okay, it's not going to be 6, all right? If this bond wasn't paid semi-annually, it wasn't going to be 6, all right? If I'm saying if it wasn't being paid semi-annually, it would have been 6, right? So in this case, N is 12 to the power negative 12 divided by 0.025 plus R 0.025 power negative 12. All right, so we do our tabulation. So we're going to say 1.25, 1.025 to the power negative 12, get 0.7435. Right, then 1 minus 0.743, 1 minus 0.743, that's we get 0.2257. We write it here was 40. We have 0.257 divided by 0.025. Right, plus, all right, so we said 1.025 to the power negative 12 is 0.743. So I want 0.743, right? And you can solve here. 0.257 divided by 0.025, we get 10.28. So we have 40 times 10.28 plus 743, right? So 40 times 10.28, that's 411.2. So here we have 411.2. And if we add that with plus 743, do that 411.2 plus 743, we get 1,000. The market price of the bond is 1,154.2. So we can see that the market price of the bond is greater than the coupon rate. All right. Our yield to maturity, let's see. Our yield to maturity is greater than is less than our coupon rate, right? And when our yield to maturity is less than our coupon rate, the market value is greater than the face value. So the bond is being sold at a premium. All right, this bond is being sold at a premium. So that's how you deal with bonds which are paid semi-annually. If it was quarterly, Wherever you would have substituted n with 2, we would have had 4 here. Our yield to maturity would have to divide by 4. Our coupon rate divided by 4. All right. So we are done with the question.